want to look at here, is that recording yet?
Yeah.
It is? Something doesn't seem right here, kiddos. So it was recording. Here we go. So we got through example 3 yesterday, is that correct?
Yeah.
So I think example 4 is a great place to kind of revisit where we were at. We said yesterday, when you're rewriting and graphing a rational function here, you are going to rewrite g of x. Okay, is this in the form that we like or a form that we don't like? We don't like this, okay? We do not like this. So it would be really nice to graph this if I could turn this into what form again, kids? Yep. So we want this form right here, don't we? A over x minus h plus k. We're going to graph the function then, and then we're going to describe the graph of g as a transformation of the graph of f of x equals a over x. Okay? So we've got some long division to do here, don't we? Long division's your favorite, isn't it? Jasmine, you were doing this. If you're going to do that, lay on your side and do it. And then I'll ask you the question. Sound good? Okay? Because then when she's laying on her side and does this, it means really yes, right? Did you know that when you're laying on your side and you shake your head no, it really means yes? Ponder that for a while. Okay? All right, here we go. Help me out, kids. What do we have to divide? What do I have to do? 2x plus 5. All right.
X plus 2.
Okay, divide this by x plus 2. So I want to look at the leading coefficients of my highest degree. So in this case, I'm looking at x, and I'm looking at what else, kids? Okay, how many times will x go into 2x? All right, help me out, kids. So this goes in there twice. Okay, we have to take this part of the quotient times our divisor here. So we have to distribute. So what's going to come down to the bottom here? All right, so we're going to subtract that whole mess right here. And it's really pretty nice, kids. What are the two x's going to do to each other? How about the 5 minus the 4? Okay, so we have a remainder of 1. Okay, positive 1, right? So if I look at an example like this, we talked about this in the past. If I go something simple like this, like 17 divided by 3, how many times will 3 go into 17, kids? What's your remainder? We call this 5 and what? 2/3, right? But we're calling this 2 and 1 over x plus 2, right? Okay, because the remainder is 1, so we're going to have, right? Now, what you want to do here, kids, is this. When you get that remainder taken care of there, you want to take that remainder and move it out to the front, because when I do this, this 1 over x plus 2 is positive or negative, kids? Okay, so doesn't this really become 1 over x plus 2 plus what? Well, that thing's noisy today, isn't it? Probably get a Ford sticker and throw on there, right? What do you guys think? Is this in a nicer form now? Does this form appear to match this form up here? Okay, so let's talk, kids. Let's talk. Where is your vertical asymptote going to go then, given this form? Be -2, wouldn't it? Because what would go down here to make this 0? Okay, it's kind of the opposite of this value down here on that form. So we're going to have a vertical asymptote at what value again? -2. Okay, so at -2, I'm going to draw my vertical asymptote in right here. Boom. Okay. Where's my horizontal asymptote going? +2. You guys with me on that? Buying what I'm selling at this point? Okay. By the way, why don't you guys plan on maybe taking tomorrow off? Have you guys heard the forecast?
Yeah.
Not looking good. Did your first hour teachers tell you what the board decided last night?
What did they decide?
June 5th. June 5th is your last day. Now my question, you want to know what my question is? What happens if tomorrow's canceled?
June 5th.
I like the way you guys think. There was nothing in there that said you were making out. It looks like June 5th is your last day. Oh, and by the way, those PD days, No, you don't.
We don't have
They're
to
not making
come.
you come to school those days.
Wait,
Really?
They decided against that.
wait, we aren't coming next Monday?
Mm-mm.
So then.
That's my
They
birthday.
canceled the ACT
Happy birthday.
practice.
Okay, what's that?
I'm in school.
They canceled
I
our
thought I was gonna
ACT
get-
practice because it was supposed to be here on Monday.
Yeah.
What ACT
So we don't have
practice?
to be
We
here.
had an ACT practice next Monday, but they thought that we were gonna be here, so they canceled it. So I wonder if they're gonna call that back. on.
Rescheduled. Are they paying the company to come in?
Yeah.
Read your announcements today. I just put an announcement in today. Starting in March, first Tuesday in March, I'm going to start offering 7:15 to 7:55 ACT math prep. We're going to work on some problems. I'm going to give you some pointers. So if you're interested in it, stop in, visit me. Okay, hey, we're doing great. I'm off task. You understand our asymptotes here? So basically, we've taken the coordinate plane of the form AX. We've moved the X and Y axis to say, hey, this is where our asymptotes are going to lie, so we've got to make a hyperbola around it. Talk to me about my hyperbola now, kids. Is that going to fall in quadrants 1 and 3 or quadrants 2 and 4? How do you know 1 and 3? What's positive? The 1 is, okay? So here's the deal, kids. This is kind of a tricky one. Whoops. The 1 right here is, I agree, positive right here. Okay, that 1 is now non-existent. But the 1 is positive there, okay? So that means 1 and 3 for quadrants. So guys, since it's a 1, from my new origin, I go over 1 and up 1. There's a point that we get. And I go over 1 and down 1. And really that's going to be the apex of your hyperbola. So you just need to make a sketch to fit that now. So I'll do my best. It's going to start out high like this, come down through that point, and then run all the way down here like this. And then same thing here, it's going to run close to that horizontal asymptote. It's going to curve at that corner, head on down this way. There it is. Okay. Do you guys, let me ask the question. Bell.
Wait, so whenever the top is a positive, it's one, quadrants 1 and 3.
Mm-hmm. And when A is a negative, where do you want to throw that? You want to know the reason why? Okay. Think about the first quadrant over here in this normal coordinate plane. All your x's are what kind of values? All your y's are what kind of values? What's a positive divided by a positive? So that's the relationship right here when I throw that in there, okay? Think about quadrant 3. What kind of values do you have on the x? And what kind of y values do you have in quadrant 3? Negative. But a negative divided by a negative when I'm comparing those two quantities would still be a what? That's why that positive. So we always consider quadrants 1 and 3 to be like a positive quadrant when you look at both x and y values when you relate them. And we always look at 2 and 4 as negative quadrants because if I go left, x's are negative but go up, y's are what? So what's a negative divided by a positive going to be? Negative. That'd be like my negative quadrant. So if this a value, if this constant out front indicates that we've got a negative function, that's why we're in 2 and 4. Again, 4. Positive, negative, positive divided by negative would be a negative quadrant there. Okay? Does that answer your question?
Yes.
So if it's positive, it's where, Bella?
1 and 3.
And if that a value is negative,
2 and 4.
there you go. Now, guys, I was only able to get 1 point. If you remember yesterday, we got multiple points on this, but it's kind of tough because the value I have here is only what? Had this been maybe like a 3 up here, I would have gone right 1 and up how much? And then I would have mirrored that, gone right 3 and up what? 1, and you would have had something that stretches away there, vertically stretches away from that, okay?
How do you figure that out? I was totally.
Okay, so I'm going to go back to example 3. Is that okay? I think that this will answer your question better. Let's go back to example 3. You guys have example 3 down, right?
We don't have it graphed.
We don't have it graphed yet? Sweet, no problem. Let's talk about it. What did this divide out to be yesterday? Was it 3?
It was -7 over
Okay,
x
so
plus 2
-7 over x plus 2. Oh, this is a great example.
plus 3.
Plus 3, right?
Yeah.
So we haven't graphed this yet?
No.
Awesome. So where's your horizontal asymptote going to lie, kids, and vertical asymptote?
-2.
Okay, the horizontal is at, well, so the vertical would be at -2, right?
Right.
And where was our vertical, or I'm sorry, our horizontal asymptote?
+3.
Y equals 3. So let me just sketch those in there real quickly, okay? This is going to create a great example. Whoops. Okay, so I've got a horizontal, you said at +3, is that right, kids?
Yeah.
What? Okay, so I've got that. And then what was my vertical, kids? -2. Screwed that up a little bit. You guys okay with that? Okay. Belle, I'm coming back to you. 1 and 3 or 2 and 4? Okay, negative, right? 2 and 4. So this value right here, what this value tells me is it tells me, oh shoot. It tells me how far to go. So when I run off of this asymptote, this is going to be like a vertical stretch of 7. So like when I went 1 over and 1 up with the 1, this is telling me to go 1 over now and stretch it by what? 7. So that first point right here, that first point really is to go right 1 and up 1, 2, 3, 4, 5, 6, 7 units. If it was 3 units, I would have gone left 1 and up how much? 3. But these are a mirror of each other. There's like a line of symmetry through here. So if I go left 1 and up 7, I can also go left 7 and up how much? Okay, and these would be really good points to make your sketch here. So, and again, doesn't it make sense that if this value gets bigger, that the hyperbola gets pulled away from the center or the intersection of our asymptotes? Doesn't that make sense? So the same thing's going to happen in quadrant number 4. From our new origin right here, or our new intersection of asymptotes, I'm going to go right 1 and down how much? How much did I go down?
7.
Because the A value was some form of A. 7. And then I can mirror that. Instead of going right 1 and down 7, I can go right and then down 1. And there's 2 pretty good points to draw a sketch of your hyperbola in there. P, I think I understood what you were asking. I was a little unsure, but does that kind of answer what you were trying to get at right there? How do you know the counting part?
Right.
Okay.
I thought
Yep.
maybe you had to do something with the bottom.
The hard part on that last one is, what was our A value in example 4? Wasn't it 1 in example 4? It's like go right 1, up 1, which is the same as going up 1 over 1. They're falling in the same spot. So you're only going to get 1 point with a 1. Any other number, how many points should you get in each quadrant? Okay. All right, so P, that's a great question. Is everybody kind of on board with that right there? All good over here? All right. So where are we at now, kids? Last one. Do we have one left yet?
Yeah.
I'm going to make sure. Does everybody have this? I need to go back here, kids. Did we state the domain and range on example 3? We said the domain was all real such that x does not equal what? And we said the range was all y values, or all real values such that y cannot equal 3. Okay? Do we have to do that on number 4? Do we? Does it say state the domain and range also for this? No. If I had to ask what is the domain here, you'd say what? All reals except for x cannot equal -2. How about your range there, kiddos, on that one? All reals such that y is not. You guys are great. You've got this, okay? Look at all these great things you're doing. Complex and difficult. I love it. Ooh, this problem's going to be a toughie. All right. Modeling with mathematics, kids. Company purchased what? What's a blueprint plotter? Anybody know that?
It's a machine
Probably like a great big.
that makes blueprints.
Yeah. You ever seen any of those that makes like the big diagrams and the big drawings? They're like a great big printer. They're like this wide, and they stand on legs, and they make all kinds of stuff. Okay. Sam, did you have a question?
I don't think so.
Okay. It says the blueprint plotter costs how much?
15.
Okay. It says the plotter cost for each set of blueprints is what? Okay, so if I own a company, I say, I'm going to buy this machine because maybe I print blueprints for houses. Maybe I make floor plans. You ever seen floor plans in a big blueprint before? Okay. Well, my company just bought this printer for how much money? $1,500. And every time I make a print, that's a cost of how much to me? So if I made 3 prints in one day, what's my total cost already? Printer and blueprints together. $1,575, right? It's like the $1,500 printer plus $25 times every print that I make. You guys agree with that? Now, here's the deal. It says estimate how many blueprints must be plotted for the average cost of the blueprints to be what? Oh boy. Okay, average. Define average again. Okay, so the number, your total divided by the number of things you have, right? Let's talk about this right here. First of all, we walk into this place, okay? I'm going to use some variables. I don't know. I'm going to let y equal the total cost. Wouldn't the total cost y equal 1,500 plus what? Cost of the printer plus $25 for not just one print, but each print. So plus 25 what here? Okay. Y is going to represent our total cost. Okay. So I don't know how many prints we're going to make, but what I'd like to know is what are my prints going to average $75, including the price of the machine. So what they're getting at is this. They're saying the total cost here would be equal to 1,500 plus 25x. But how many prints are we going to make? How many prints are you going to make? Okay, so wouldn't the average be this total divided by the number x right here? Okay, so my average rate here then would be 1,500 plus 25x all over what, kids? Whoops. Gosh, this is not working very well anymore. I need a new one. I want the Mimeo that I can just touch up here. Maybe I'll write a grant for that now. Got a timing system here, and now we need a new Mimeo system. There's the average function right there. They want to know how many prints we're going to have to make so that the average falls to what? They want to know what x is equal to when the average is what value here, kids? So what am I going to plug in for the average? 75. That's going to equal 1,500 plus 25x all over x. I don't like that x in the bottom, so what can I do to both sides? Multiply by x. So what's the left side going to become, Sam? 75x equals 1,500 plus 25x. Let's see, variables on both sides. This should be clockwork for you guys now. What have I got? 50x equals 1,500 divided by 50. How many? You said 30, is that right? Let me make some room up here. Oh, darn it. So how many copies, or how many blueprints do we need to make so that the average is $75 a copy? That includes the machine and the copies. Well, it would be 30 blueprints. Now I want to show you something here, kids. The more blueprints I make, what's going to happen to the average? Is it going to come up or come down? Think about it. The one cost was $1,500. Now we're paying $25 each time. It's like averaging $1,500 and then 25 and then 25. And the more 25s you keep adding, my average right away, one copy. Is that pretty high or pretty low for the machine and a print? Pretty high. But the more prints that I make, what should start happening to the average cost of prints? It's like starting, you got this big one, 1,500, that's like an outline. Then you got a bunch of 25s that you're going to average together with that 1,500. That should start to do what? Okay. What function do we come up with for the average, kids? Wasn't that it right there? Let's just throw that into decimals quickly and see what happens here, what this looks like. Somebody read that function to me. What was it? Y equals what?
1500 plus
25x?
Yep.
And then we were going to divide that whole total by what? Okay, I obviously need to zoom out because we're working with some pretty high numbers here. Wowzers, kids. Now I'm not going to worry about this third quadrant down here because we can't have negative blueprints, can we? So I'm going to look it over here, okay? Very few prints, kids, very few prints is the cost high or low. The more prints I have, what happens to your cost? Starts to get lower and lower. What do you think this horizontal asymptote is really close to? 1,500 you started with plus a bunch of 25s. Eventually it's going to start to flatten out towards $25. So the next question in here, kids, and by the way, isn't this an example of a hyperbola? Makes sense that we've been talking about hyperbola, so here's a problem that models a hyperbola. Help me out, kids. What am I going to write here? It says, what happens to the average cost as more blueprints are printed? Okay, so you're going to say, put it in words for me. As this, then this. Okay, they want to know what happens to the average cost as what?
As more blueprints are
Okay, so as more blueprints. I'm writing in blue. Here's my blueprint. Come on, I thought that was pretty good. Wasn't that good? As more blueprints are produced, the average cost is doing what, kids? The average cost is increasing or decreasing? What do you want to throw there? Is decreasing, you bet. Will the average ever get down to 25? Or will it get really, really close to 25? What number is keeping it from getting to 25? Every print was $25, but we were also including the price of the machine, right? That 1,500, once you throw that 1,500 in there with every single 25, your average will never ever be 25. The more 25s you add, the closer you're going to get, but you will never ever get there, okay? All right, kids, questions first of all, notes. Jazzy. Okay, let me make sure I have everybody has this down, then we'll go back to that, okay? Everybody good? Example 4 here? Okay, Jazzy, what did I mess up here in 4?
I was just wondering because there's a second part that says describe the graph of G.
Okay, so let's talk about that. Really what's happened here is this. Once you've defined your asymptotes right here, let's just talk about this. This x plus 2 down here, this x plus 2 part, any is like something in parentheses down there. And anytime you got a plus value in parentheses, that's like saying, hey, we're going to move everything to the left 2 units. Didn't your vertical asymptote, which was originally the y-axis, move 2 to the left here? Okay, and then how about this plus 2 just kind of hanging out here on the end? We've talked about so many translations here. If I throw a plus value on the end or a minus value, that has the effect of translating everything up or down. Well, that plus 2 would indicate that's going to move this up 2. So originally, the horizontal axis or the x-axis was your original asymptote of the form a over x, but where did that move to, Jazzy? Up 2. So yeah, good catch there. I would say your description then is that everything moves. The x plus 2 part has an effect of moving stuff left. How many units? Okay, and then the plus 2 out there on the end has the effect of moving this, everything up 2 units. Good catch. I didn't even read that, so thank you. Everybody clear on what she was asking there? We just forgot to answer the last part of the question. What if this was down here, maybe x minus 4? If it was x minus 4, then what would you have said? Right, 4. What if this was minus 6? That's all you're doing with that, okay? All right, good catch, kid. All right, are we good now? Any other questions? Very good. I'm going to stop this here. We'll get this loaded here.